I was like, but I was so lost. I didn't know what was going on.
That must been so.
There we go.
It's like, yeah, I still.
Here they come.
He's in here.
All right, sorry guys, thanks for your patience. I think I might have like logged into the wrong one. But the good news is we really haven't done much. We just started reviewing, so you haven't missed anything. Sorry about that. All right, so we were just reviewing section 5.2, talking about our bisectors of a triangle, and we talked about how there are bisectors for each side of our triangle, and there's bisectors for each angle. And we talked about when they overlap, that means that they are concurrent. And we have a point of concurrency when we're talking about our lines that overlap for segments. And then we have the in center is going to be where they overlap for angle bisectors. Okay, so we were just doing the guided practice on 275. Number one, we had said that 3 or more lines intersect at the same point and they are concurrent. So for number 2, it says, think of something about the words in center and circumcenter that you can use to remember which special parts of a triangle meet at each point. Okay, so if we're talking about in center, all right, so think about in center. Which one does that go along with? Does that go along with our segment bisectors or our angle bisectors?
Angle.
Goes with our angle bisectors, right? So if we're talking about in center, we're talking about angles, okay? And so when I'm talking about circumcenter, I'm talking about the side. So if we think about, let's see, circumcenter is on 273, and it just shows where the circle is about the triangle. It is on the outside, and it says the point of concurrency of the perpendicular bisectors of a triangle is called the circumcenter of the triangle, okay? And so in each triangle at the bottom of 272, we looked at that, and so we said that it could either be inside the triangle, on the triangle, or outside the triangle, okay? So anything that you can think of to help you remember, like we talked about the circle of the circle around, so like if you look at 5.5, the circle around the triangle is circumscribed. So therefore, if the triangle, if the triangle is circumscribed, then it has a circumcenter, okay? Now the in center, think about the circle is inside the triangle. So in center and inside would be kind of a way that it would help you remember. That's not what I want on the screen. Okay, so let's look at number 3. It says, use the diagram and the given information to find the indicated measures. So look at number 3. The perpendicular bisectors of triangle ABC meet at point G. We need to find GC. All right, so I'm looking at this diagram here. What information do I know from looking at this diagram and understanding bisectors? What do I know about what lengths are congruent?
Where are you?
I'm on the guided practice number 3.
BF and FC.
Okay, so let's take a look. So what does it say? What did you say?
BF and FC.
BF and FC are, okay. What do I know about, if I've got 5 right here, what do I know is this measure here?
5.
It's also going to be 5, right? So I'm going to go ahead and label that. Okay. What do I know if we look back at We're trying to find GC. So what do we know about AG, CG, and BG? What did we learn about those bisectors?
Oh, current.
Okay, they do cross over, but look at theorem 5.5 for just a minute on page 273. Theorem 5.5 on 273 says, 5.6. Okay, it says the perpendicular bisectors of a triangle intersect at the point that is equidistant from the vertices. So notice that PA is equal to PB, which is equal to PC. Now let's go back to our figure. If I'm looking at AG, CG, and BG, what do I know about each of those measures? They're equidistant. What is the measure of AG? 7. Therefore, the measure of CG is going to be what? 7. Good. And so that's what the question asked us, was to find GC. Okay. So each of those red lines we just read based on that theorem is that they are equidistant. So if I know the measure of one, then I know the measure of this one as well as this one. Okay. So understanding that theorem, understanding that it's telling us that they are going to be equal to each other, helps us to know those measures.
Equidistant, you have to have like a normal something, you have to like, know that it's equidistant. Like, can you just like look at it and say like it's equidistant or not?
Well, in this particular situation, you've got to be able to, what they are wanting you to do is to be able to understand the theorem, and that if it is a perpendicular bisector, that it's equidistant. Okay. And so remember when we talk about, or that one's the angle bisector. So we know angle bisectors are equidistant. Now let's go ahead and look at number 4. What is the difference here? So notice number 3, we were dealing with our angles, right? We were dealing with angle bisectors, and we said that those were equidistant. Now we're doing segment bisectors. What do we know about those? What about the segment bisectors? Look at theorem 5.6 on page 274. Notice those red lines. So what are they going to be?
90 degrees.
No, not the angles. I'm talking about the distance of those lines. Notice that from each side to the center is going to be congruent. So if J to M is 5, what is K to M going to be? 5. What is L to M going to be? 5. Good. So they asked us to find MK, so that's going to be 5. By knowing and understanding those two theorems, I know that I can use a measure that they have given me to determine other measures. Okay. Now notice in the first one we did, when we were talking about it, is our red lines that go from the vertex to the center. That was equidistant. Now here, when we're going from the side to the center, when we're doing our perpendicular bisector, that is where it's going to be equidistant. Okay. So let's go ahead and take a look at the homework for this section. We will start with number 10, 11. Let's see. We're going to do 11 through 19 odds. Okay, so in this section, page 275, 276, 11 through 19 odds.
What was the homework from last week? Wow, so yesterday.
From yesterday, we only had from 5-1, it was 9 through 19 odds, and we omitted number 15. So 5-1 is 9 through 19 odds, no number 15, and then 21 through 26 all. So now we're adding to that. Now we're adding to that where it's going to be page 275, 11 through 19, or 275, 276, 11 through 19 odds. All right, so let's move on to 5.3, medians and altitudes of a triangle. We've been talking about bisectors, okay? So obviously that's a term you need to know and understand the definition of what a bisector is, and understanding that a bisector can be on the side of a triangle or the angle. Now we're talking about medians and altitudes of a triangle. It says in 5.2, you studied two special types of segments of triangles, perpendicular bisectors of the sides and angle bisectors. In this lesson, you will study two other special types of segments of a triangle, medians and altitudes. A median of a triangle is a segment whose endpoints are a vertex of the triangle and the midpoint of the opposite side. Okay, so a segment whose endpoints are a vertex of the triangle and the midpoint of an opposite side. So that means it's going to start at the vertex. Remember, the vertex is going to be any of my points, and it's going to bisect the other side. Okay, it's going to go to the midpoint. Now remember, earlier we didn't necessarily worry about whether or not my bisectors crossed over at a midpoint. We could not necessarily know that it was going to break a side into half, into two equal pieces. But with a median of a triangle, starts at the vertex and it touches a point on a side at its midpoint. For instance, in triangle ABC, shown at the right, D is the midpoint of side BC, so AD is a median of the triangle. The three medians of a triangle are concurrent. So just like the bisectors, medians are concurrent. The point of concurrency is called the centroid of a triangle. So remember, we've talked about how we talked about earlier how the concurrency of my bisectors was called the circumcenter. And then we had the end center was where my bisectors of my angles crossed. Now we have the centroid of a circle, and the centroid is the point of concurrency of my medians. Okay, so three medians are concurrent, and where they cross over, the point of concurrency for those is called the centroid. So now if we look at these diagrams, the centroid label P in the diagrams below is always inside the triangle. So centroids are always located inside the triangle. So we have an acute triangle. What do we know about an acute triangle? What does that mean? All angles are less than 90 degrees. Good. So you can see where my medians go from each vertex, and they touch the side of a triangle at its midpoint. Right triangle. What do I know about a right triangle? I have one 90-degree angle. Okay. So again, even though it's a 90-degree angle, I've got my median goes from my vertex to the midpoint of the side. Therefore, if I know it is a median, I can also look at it and say, hey, I know that these two sides are congruent, these two sides are congruent, and these two, because the median has cut it. Now remember, the bisector does not necessarily mean that they're going to be congruent on either side, but a median does.
So what's the median? What line's the median?
In this particular one, remember, there's going to be three of them each triangle because there are three vertices. Okay, so there's going to be three bisectors, there's going to be three angle bisectors, there's going to be three medians. All right, so what is an obtuse triangle? What does that mean?
More than
It has at least one angle greater than 90 degrees. All right, so theorem 5.7 says the concurrency of medians of a triangle. The medians of a triangle intersect at a point that is 2/3 of the distance from each vertex to the midpoint on the opposite side. This is something you just have to memorize, that when you're dealing with a midpoint, it is 2/3 of the way from the vertex to that point of concurrency. Okay, so I know that if this is 2/3 of the way, then from the point to the midpoint is going to be how far? Do it.
A third.
A third, yeah, because 3/3 is one whole, right? So if this distance is 2/3, then I understand that from P to F would be 1/3. So it's the kind of thing that if they were to only give me the measure of this one, and I need to find the total, I'm going to have to use a calculation knowing that this segment is 1/3 of my entire line, or that this segment is 2/3 of my entire line, okay? So let's go ahead and take a look. Let's go ahead and look at example 1. P is the centroid of triangle QRS shown below, and PT equals 5. Find RT and RP. So let's look at our diagram. They have told me that PT equals 5, right? So I'm going to go ahead and label that as 5. Whoop, not with my highlighter. Yes.
So would that make PR 10?
Let's see. Okay, so if that is 5, and I have 1/3 equals 5, then what is 2/3?
10.
10. So if this side is 5 and this side is 10, what is the total measure of my whole median? 15.
Oh.
Okay. So I can look at that, and so it says because PT equals RT minus RP, and I know that PT is going to be 1/3 of my whole line. I can go ahead and substitute 5 for PT, so 5 equals 1/3 of line RT. Now, if you would rather use X, you could also do that. So basically, you would just say that 5 equals 1/3 of X, okay? Now, remember, if I have a fraction that I'm trying to clear, how do I eliminate the denominator? How do I get rid of my fraction? What type of problem is 1/3? Huh? It's a fraction, which is what kind of operation?
Multiply by the denominator.
It's division, so I have to undo it using multiplication, so I'm going to multiply by the denominator, okay? So in this situation, if I multiplied everything, both sides by 3 times 5 is 15, and then my 3's cancel out here, so 15 equals X. So I know that RT, or that my whole entire segment, is going to be 15, because basically what I said was I just went ahead and let X represent RT. You can either leave it as the 2 letters so you know exactly what you're subbing for, or just stick a variable in if you're more comfortable with that. But either way, think of, basically just think about 1/3 of my whole line equals what number? Or 2/3 of my whole line equals a number, okay? And when I say the word of, what operation does that indicate? Multiplication. So if I said 1/3 of 15, then I know I'm multiplying 15 by 1/3, okay? So we found that if PT was 5, then RT was 15, which means that RP would be 10. All right, let's look at example 2, finding the centroid of a triangle. Find the coordinates of the centroid of triangle JKL. You know that the centroid is 2/3 of the distance from the vertex to the midpoint of the opposite side, okay? So if I know that, then it says I need to choose the median KN, okay? So if I'm looking at my median there, I know that I'm going from point K to point N, and that's my median. It says find the coordinates of N, and then the midpoint, N is the midpoint of JL. So if I'm looking at JL, I'm using N as the midpoint. Remember, what is my formula for midpoint?
P plus X1 over 2, like, comma, I guess.
Well, yeah, I mean, it's remember that my midpoint is going to be an ordered pair X and Y. And typically when we put X and Y in parentheses, we have X comma Y. So we add our X's and divide by 2. And what do we do with our Y's? Add them up, divide by 2. Okay, so to be able to find that midpoint. So then it says find the distance from vertex K to that midpoint. Okay, so again, whenever I'm dealing with a grid, if it runs along straight lines and I can count it, that's great. Okay, just use your units on your grid to be able to count. But if it's going to be a slant that you can't count directly, like if you were having to find the side of a triangle, you could use the distance formula to find the distance. But here I'm just counting from K to N and it's going straight along the line. Okay. So it says the distance from K, which is 0.52, to N, which is 5.8, you would just say 8 minus 2 is 6 units. So basically, if my point N, it said 1, 2, 3, 4, 5. So my point for N is 5.8. So I'm just subtracting my difference of Y. If this one up here is 8, 7, 6, 5, 4, 3, 2. Okay, so I know that I've gone down 6 to get to 2. So now it says determine the coordinates of the centroid, which is 2/3 of 6. So remember, if my total distance is 6, to find the centroid, so I'm right here. So to find the centroid, I know it's got to be 2/3 of 6. And 2/3 of 6, remember, if I'm multiplying, that would think of 6 over 1. So if I multiply 6 times 2 is 12, and 3 times 1 is 3. So 12 divided by 3 is 4. Remember about multiplying fractions. Okay, so you know it is 4 units up from vertex K. So then if I'm looking at my ordered pair 5, 2, and I need to go up 4, then my centroid will be at 0.56. Okay. So it says exercises 21 through 23 ask you to use the distance formula to confirm that the distance from vertex J to centroid P in example 2 is 2/3 of the distance from J to M, the midpoint of the opposite side. Okay, so you know that we've got midpoints and distance formula that we're going to need to be remembering. Remember when I said if you haven't memorized those yet, you need to memorize them because we're going to be using them a lot. Okay, so that was a median of a triangle. Now we're going to talk about the altitude of a triangle. The altitude of a triangle is the perpendicular segment from a vertex to the opposite side or to the line that contains the opposite side. Okay, so perpendicular segment. So what do I know about this one? When I say perpendicular segment, what does that tell me?
One that intersects.
Intersects at what? 90-degree angle. Good. So some of these other ones we haven't necessarily worried about, like with a median. It doesn't necessarily, I mean, it's not intersecting at a 90-degree angle. It does intersect at the midpoint, but it may not be at a 90-degree angle. These with an altitude, it is intersecting at a 90-degree angle. Therefore, an altitude is not going to intersect at a midpoint, because it has to be a straight line and has to intersect at a 90-degree angle. It may end up intersecting, so you can see here that my altitude goes straight to the other side and intersects at a 90-degree angle. Therefore, these two sides are not congruent. Okay, so medians give us congruent sides, altitudes give us 90-degree angles, not congruent sides. Go ahead and take a break.
Can I see on computers, right? I was like, what?
I really hope whoever's doing this stuff to the Michigan and not Michigan, Georgia stuff and whoever else is doing and cheating. As I say cheating, it's pronounced cheating. Whoever's doing that, I hope they get arrested. Or something like that. One of my friends is like, even if Biden becomes president, he's probably gonna be impeached. And he's not gonna be able to survive.
Well, I mean, it's the kind of thing that at this point, I mean, it's so crazy. Who knows what's going to end up happening?
Yeah.
It is such a toss up.
My
And,
sister-
and both sides are going to complain. Everybody's going to cry foul. It doesn't matter who wins. Everybody's going to, both sides are going to be crying foul. And so
my sister was like,
it's really a lose-lose situation.
my sister and her boyfriend were like, it's probably not gonna be till like the beginning of December or end of November till they actually figure all this out. Because they're probably in the Supreme Court, because I know Trump's gonna do all he can. So, and Trump's lawyers are not gonna let them. So, Trump's like, he's like,
That's the thing I was gonna do.
he's gonna realize.
Maybe not. She might not. I was gonna think that they have that. Wait. I added 2 more chairs to Alex too. He has 4 chairs and probably now. He's downstairs. This guy's not none of that.
And he said, you know, something
Oh, you need to you're like, you just
He actually gives you a realize. What?
what I do?
I mean, I don't think I was okay. You're fine.
He did it. He did it.
Do you feel taller?
I feel high. That's good.
You don't need chairs.
That's a good feeling.
Alex, you got he doesn't hold back when he talks.
Oh, yeah. He does not hold back at all.
I can't fight.
Dude, there,
Can you blame me though? Don't
No,
it's
I
terrible.
can't.
dude,
I
we-
haven't even been, and I don't like it.
dude, when Alex went off and everyone rolled his dog, and we were like, it was so.
I'm tired of these people always putting on their choice school conference tonight, team, best team in the country. Okay. I'm sorry, no one does.
We all know it.
No,
And we're
We know you
I
pay the rest
respond to
$1
stories.
million.
respond to their story, be like, no one asked. Like,
And we know y'all pay the rest like $1 million per game.
they have like 25 football stadiums, their TV stadiums nicer than the American. This lady.
Dude, their middle school, like, Crawford Middle School got the.
I don't know if the coach is the same that it has been for the past years,
My
but
students
if
broke.
so, it's Alabama's old
My
teacher.
students
I
broke.
guess not George Hamilton, but
Look.
Thompson doesn't experience the coaches that don't get paid. The coaches that don't get paid are the real. That's a fact. That's the big party. No, I know. I'm not.
Alrighty. So we just looked at the altitudes. We talked about how with our altitudes, they intersect at a 90-degree angle. Because they have to intersect at a 90-degree angle, they are not going to intersect at a midpoint, which means that where they intersect on each side will be congruent. Okay, so that's going to be the biggest difference between a median and an altitude. So let's go ahead and let's see, it says, draw an example of each type of triangle and locate, every triangle has 3 altitudes. So we said there's 3 bisectors, there's 3 angle bisectors, there's 3 medians, there's 3 altitudes. Okay, so now we've got 4 different parts. So it says every triangle has 3 altitudes. The lines containing the altitudes are concurrent and intersect at the point called the orthocenter. Okay, so now we've talked about a circumcenter, we've talked about an incenter, we've talked about, what was our last one? The centroid, and now we're talking about an orthocenter. Okay, so all of these different things are all talking about the point of concurrency of either a bisector, an angle bisector, a median, or an altitude. Okay, their own name. So now it says drawing altitudes and orthocenters. Where is the orthocenter located in each type of triangle? So if we look at an acute angle, we start at each angle. So from angle A, I go directly to B, where I'm to E, where it would intersect at a 90-degree angle. Same with B to F, C to D. Okay. With my right triangle, notice that when I have a right triangle, I can only go from M to J. K to M to intersect at a perpendicular is going to give us, it's just going to be line KM. Okay, so if I was going from this angle or from this vertex down, it's just going right there. Same thing with going from L to M. Because notice, I mean, it's so to be able to make a perpendicular line at a 90 angle, we're only going to have 1 altitude angle. Had 3 for an acute. We only have 1 altitude, or I guess realistically, we would say it would have 3. One of the altitudes would be KM. The other would be LM. Okay, so those. And then finally, if we look at this next one, okay, so so where is the orthocenter? Sorry, hold on a second. Where was our orthocenter of our first one? What was our point of our 3 lines?
G.
Point G, right? There was our orthocenter. Our orthocenter going to be of our right triangle.
Yeah.
Where are all 3 lines going to intersect? Remember, if this was 1, this was 1, where are they all intersecting? At what point?
M.
Point M, yeah. So point M is going to be my orthocenter of my right triangle. Now let's look at this triangle. And so it says we have an obtuse triangle. Okay, so the obtuse triangle, I was getting hung on blue lines. Okay, so going one here. This is the triangle we're talking about. Okay. So now if I were to draw here, that if I let's see. So basically going from R, you can see that it would extend that way. P would extend that way. And then altitude going from Y to Q is going to be the main one, but you can see it would extend out as well. But so where are all three of those intersect?
Why?
Y,
Oh.
okay? Hold on. IPR is an obtuse triangle. The three lines that contain the altitudes intersect at W.
WRP is one. Right? So when it is W.
Hold on a second. Let me look at that one because IPR is interesting. The three lines that contain the altitudes intersect at W. Oh, duh. Okay, sorry. This is how basically this triangle, like this obtuse, is like two right angles, right? So if we look back at the first one, if we look back at our right triangle, remember we talked about how this is one of our altitudes and this is one of our altitudes of my right triangle. So if I do the same thing over here, when I've got two of the right triangles, then that means that this altitudes, and so is this. And then we've got this one and this one as well. So when we have to extend them out like we did a right triangle, then we end up at W because we've got this one going this way. We can't forget that just like KM was an altitude here, our altitude has to go out from Q up as well. And so then ML, so then we go out that way and that way, okay? So it just says that angle ABC is an acute triangle. The three altitudes intersect at G, which is a point inside the triangle. So acute triangle, they intersect inside. A right triangle has two legs, which are also altitudes. They intersect at the right angle. This implies that the orthocenter is on the triangle. And YPR is an obtuse. So the three lines that contain the altitudes intersect at W, a point that is outside the triangle. Okay, so acute inside, right angle be on, obtuse is going to be outside. Theorem 5.8, the concurrency of altitudes of a triangle. The lines containing the altitudes of a triangle are concurrent. So if we look at AE, BF, and CD, those are all the altitudes of triangle ABC. And then we can see lines AE, line BF, and line CD intersect at some point H. So we can see that how they intersect outside, okay? So that's the concurrency of altitudes of a triangle. So let's look at the guided practice. The centroid of a triangle is the point where three blank intersect. What do we say centroids intersect? No. Medians. Medians are centroids. It says in example 3 on page 281, explain why the two legs of the right triangle in part B are also altitudes. So that right triangle we looked at, why are KM and ML also altitudes? We look back at it. Why did we say that these two are also altitudes?
Wait, on B. On example 3B.
On page 281, flip back. Letter B, the right angle. What is our definition of an altitude? What is the rule? What do we say about an altitude? To intersect at a, what type of degree angle? 90-degree angle, because it's perpendicular, remember? So it's a perpendicular segment, okay? So since an altitude is a perpendicular segment from the vertex to the opposite side, then the vertex from KM to the perpendicular, okay? So if we're looking at perpendicular is going to go each way, so each leg ends up also being an altitude. Back. All right, use the diagram shown in the given information to decide in each case whether EG is a perpendicular bisector, an angle bisector, a median, or an altitude. So now we're going to look at all four cases that we've just talked about: perpendicular bisector, angle bisector, median, or an altitude. So let's look at number 3. DG is congruent to FG. DG is congruent to FG. So we're talking about along the bottom. We're saying that DG is congruent to FG. Which one of our 4 that we've talked about tells me that my sides are congruent? Which one of them intersects at the midpoint? If you don't know, look back.
E.
No, we're asking, is it a median, an altitude, an angle bisector, or a bisector, perpendicular bisector? Look at the definition. Which one says it intersects at a median and causes the sides to be congruent? Which intersects and gives us congruent sides?
Median.
The median, yes. Okay, so our median intersects at the midpoint. Think about median, midpoint. They both start with M's. If I have a midpoint, I have congruent sides. Okay, so if I have congruent sides, I know it's the midpoint. Now let's look at the next one. It says, what if they told us that EG was perpendicular to DF? Okay, but look at this. So if it's perpendicular, if EG is perpendicular to DF, notice it leaves the vertex and goes straight down to intersect. So what did we just learn is a perpendicular bisector? What did we just talk about? Leaves the vertex and intersects at a 90-degree angle. It is perpendicular. Altitude, good. Look at number 5. Angle DEG is congruent to angle FEG.
Angle bisector.
Angle bisector, good. It's dealing with angles. Cuts them in half, angle bisector. Number 6, EG is perpendicular to DF, and DG is congruent to FG.
That would be perpendicular bisector.
Perpendicular bisector, good. We have the 90-degree angle and we have congruent sides, okay? And then finally, triangle DGE is congruent to triangle FGE.
That would be
Altitude's one of them.
Oh, altitude and medium.
And
What?
all of them. Yeah, all of them can show us that. Triangle DGE is
Oh my
congruent to
goodness.
FGE. And so it's going to be all of them. Okay, so let's look at the homework for this section. Notice in 8 through 12, use the medians of a triangle. All right, so if you do not remember your information about medians, you will need to review that section as you're doing the homework. Good thing is you'll be writing lesson notes, and so it should be right there at the top of your homework paper anyway, and you don't even have to flip back in your book. You've already got the information. So on this section, we will do, let's see, we're going to do, let's do 8 through 12 all here. 8 through 12 all. And then let's go down, let's go to the next page on 283. And let's do 17 through 20 all. Mhm. So we had 8 through 12 all and 17 through 20 all. All righty, let's go on to 5-4. We're going to start section 5-4. We will not finish it today, but we'll at least get started with it. Okay. So now we're talking about the mid-segment theorem. Using mid-segments of a triangle. It says in lesson 5-2 and 5-3, you studied 4 types of segments of a triangle: perpendicular bisectors, angle bisectors, medians, and altitudes. Another special type of segment is called a mid-segment. A mid-segment of a triangle is a segment that connects the midpoints of 2 sides of a triangle. So it's a segment that connects 2 midpoints. So think about if I have a triangle, okay? So if I have a triangle, then I know that these are congruent, so I know I'm going to have, what am I doing? I'm trying to write on the board. I've got that midpoint, okay? So if I had a midpoint on that side and I had a midpoint on this side, I could connect those, okay? So that would make a mid-segment. So basically, I'm taking 2 midpoints and connecting them. So as you can see, and the example they're giving us is about folding paper. You can form 3 mid-segments of a triangle by tracing the triangle on paper, cutting it out, folding it, and showing it below, okay? So you can see where after you've folded and you've shown, so basically, in this triangle here, you can see where I would have my midpoint here connected to my midpoint here. I could have a midpoint here connected to a midpoint here, and then these 2 midpoints. So I have 3 mid segments. Is everybody good with that? So I'm connecting the midpoints on each line. So look at example 1. It says, show that the mid segment MN is parallel to side JK and is half as long. So if I'm talking about midpoints, what formula do you think you're probably going to need to use? The midpoint formula, x plus x divided by 2, y plus y divided by 2. Okay, so that's how I find my midpoint. So it says use the midpoint formula to find the coordinates of M and N. So I would take my coordinates of K and L to find N, and I would use my coordinates of J and L to find M. Once I have those, then I can use, I can connect those lines. Now it says next, find the slopes of JK and MN. Slope formula. Slope is equal to what over what? Rise over run. So it's my vertical change over my horizontal change. And remember, when I'm dealing with slopes, that's where I have y2 minus y1 over x2 minus x1. Okay, so again, these are formulas that you need to know. Notice they didn't even tell you. They didn't give you the basic formula. They just plugged in values. They were expecting you to know this by now. But if you need, M is equal to y2 minus y1 over x2 minus x1. That's going to be your slope formula. You use your values, find the slope. So it says because their slopes are equal, then we know that JK and MN are parallel. Remember we learned that parallel lines have the same slope. What about perpendicular lines? What kind of slopes do they have? Parallel lines have the same slope. Perpendicular lines have slopes that are negative reciprocals, okay? It says you can use the distance formula to show that MN is equal to the square root of 10 and JK is equal to the square root of 40, which simplifies to 2 times the square root of 10. Therefore, you can see that MN is half as long as JK, all right? So if we look at theorem 5.9, the mid-segment theorem. The mid-segment theorem says that the segment connecting the midpoints of two sides of a triangle is parallel to the third side and half as long. So when I have my mid-segment here, okay, when I'm connecting D to E, this is going to be parallel to AB, all right? So those are parallel, indicated by arrows, and this measure is 1/2 of this measure. So your mid-segment will always be half of the measure of the line that it is parallel to. Again, you're gonna have to memorize this, okay? And I do believe, I'm pretty sure I've seen that on the ACT on a practice test. So that's going to be something where they give you a diagram and they'll give you a number and tell the measure. You have to tell what the measure of the other one is, and you have to understand that the mid segment is half of the line that it is parallel to. All right, so it says using the mid segment theorem. UW and VW are mid segments of RST. We need to find UW and RT. So let's look at our diagram so we know what we're talking about. Now, if I'm looking at the measure of this side, which is 12, okay, so RS is going to be 12. How do I know what UW will be? If RS is 12, what is UW going to be? Would it just say that the mid segment that is parallel, UW will be 6, mid is going to be half of the line that it's parallel to. So we know that UW will be 6. Now, if we look at this one right here, this is a mid segment that they've told us is 8. What is my line that it is parallel to? RT is what it's parallel to. So if this is 8, then RT is going to be what? 16, because 8 is half of 16. So RT is 16. Okay, so I can use my mid-segment theorem to understand that if I have the measure of one, I can find the measure of the other by either dividing by 2 or multiplying by 2. Okay, so example 3, we're going to kind of scoot through this. This is dealing with proving mid-segment. So it says write the coordinate proof of a mid-segment theorem. So basically it's just saying that I've got A, B, and C, and then I have my midpoints D and E. So it says place A, B, and C in convenient locations on a coordinate plane. Use the midpoint formula to find D and E. And so you can find those coordinates. Then it says find the slope of the mid-segment. D and E are going to have the same y coordinates. So the slope of DE is 0. Remember, because a slope of 0, horizontal lines. AB also has a slope of 0, so the slopes are equal, so we know that they're parallel. And then you have to calculate the lengths. Now, one of the things I want to tell you about calculating length, what symbol do you notice that they are using?
Segment.
Look under where it says calculate. Calculate the lengths. What is the symbol that they're using here?
Absolute value.
Absolute value. What do I know absolute value means? So if I have,
Absolute value of something.
if I have the absolute value of 3, what is the absolute value of 3?
3.
Negative.
What is the absolute value of -3?
3.
Why? What does absolute value describe?
Positive, like, my brain.
But why is it positive? Absolute value describes the distance from 0 on the number line. Okay? So when I'm talking about distance from 0, it doesn't matter if I'm going to the right or to the left on my number line. I'm going either 3 places to the right or I'm going 3 places to the left. So remember, with absolute value, whatever is inside my absolute value signs, whether it's positive or negative, the distance is always positive. I cannot have negative distance, okay? So remember, with absolute value, even if I had 3 minus 6 and I end up with -3 like this, my distance is still going to be +3, okay? So that's going to be something to pay close attention to, that when you're looking at these and you're looking at the distance, even though it may be negative, it's absolute value, so it's going to be positive. Let me check our time, 9:53. All right. Using properties of mid-segments. Suppose you're given only 3 midpoints of the sides of a triangle. Is it possible to draw the original triangle? So it says example 4 shows one method. So let's take a look at this method. It says using midpoints to draw a triangle. So here they have given us the midpoints of L, M, and N. Okay, they said L is at 4, 2. So 1, 2, 3, 4, 1, 2. M is 2, 3, 1, 2, 1, 2, 3. And N 5, 4. 1, 2, 3, 4, 5, 1, 2, 3, 4. So they have given us, and these are midpoints of a larger triangle. So to be able to draw the larger triangle, I'm going to have to find the slopes of each of my sides to be able to determine that. Okay. So in the solution, it says to plot the midpoints in the coordinate plane. That was the picture that we're shown. Then it says to connect the midpoints. Okay. So plot, connect the lines. Now we need to find the slopes of the mid segments. So let's use the slope formula. So let's take a look at what that means. I'm going to leave it to where I can see my numbers here. Okay, so notice when I'm dealing with M to N, okay, if I'm finding the slope of M to N, I'm using my points M and N. Remember, this is where I have y2 minus y1 over x2 minus. So y2 minus y1, 4 minus 3, x2 minus x1, 5 minus 2. So I find that the slope of this line is 1/3. Now I find the slope of N to L. Okay, so N to L, I'm having to look at point L, point N. So again, y2 minus y1 over x2 minus x1. So 4 minus 2 is 2, 5 minus 4 is 1. So 2 over 1 is my slope. Then I have to find the slope of LM. So I use my points for L, point for M. Y2 is 1 over x minus x1. 2 is 1. 2 minus 4 is going to be 2 minus 4.
2.
What kind of 2?
Negative.
Negative 2. Okay, so that means now one of the things to remember is when I'm dealing with slope. Okay, remember that a positive numerator tells me I'm going up, and a positive denominator tells me I go right. But what if I wanted to go down and left? Then that would be a -1 over -3. That would mean I could go down and left. And -1 is equal to, I'm sorry, 1/3 is equal to -1 over -3. So I want to make sure that I have my points to where I can either go up and right or down and left. So you always want to look look at your other slope that you can use in the other direction. Easton?
So if you get a negative, do you have to put it in front of both or?
I'm getting there. Okay, so if we looked at this one, this was if they were both positive. I want to also go ahead and make them both negative so I can know that I can go up and right or down and left. Now let's look at that one that was negative. Okay, so remember that -1, if I have my negative in front, that's the same as having my negative in my numerator and the positive in the denominator, or I can have my 1 in my numerator and my negative in my denominator. So notice if I've got -1/2, that means I'm going to go down and then right. But if I have 1/2, that means I go up and left. So the main thing to remember about a negative slope is that I can only have it in either the numerator or the denominator when I'm calculating my slope. I cannot have it in both, because having it in both means it's positive, because a negative divided by a negative is a positive. All right. So if I have two negatives, I know that it is also equal to a positive slope. But if I've got a negative, I can only put it in one location. But by moving, it helps me to see I can either go up and right or down and left. Okay. So I can use these slopes to determine my points. Same thing with 2. Remember, 2 is the same as 2/1, which would be the same as a -2/-1. All right. So that means I can either go up and right or down and left. So now what I'm going to do is I'm going to use those slopes to determine additional points on my line. So notice here, I had N. Okay, if I started with N, how do I get to A? How do I go from N to A? Okay, up 1, so that's a positive 1, right? Left 2. So what's the slope?
1 negative.
Okay, so I'm using that 1 -2. Notice I'm using that slope here. All right. So I'm using that -1/2 to go from N, and then I'm able to get to A. What about from N to B?
Right to down.
Think about slope. What has to go first?
Down.
Down 1
Over 2.
over 2. So this one has the slope of -1/2. Okay. What do you notice? Which slope had the -1/2 slope? It was this line right here, right? It is opposite that point. So I'm using the slope of the opposite line to determine what this is going to be. Because remember, we just talked about parallel lines have the same slope. So if this line over here is going to be parallel to the line here, they're going to have the same slope. Does that make sense? Okay, so I know that if this is my point and I'm trying to, is what I'm trying to find the additional sides of, I know the slope has to match up to ML. So that's why I'm using the slope of -1/2 to plot additional points for N. Okay, so if I'm plotting additional points for L, what slope am I going to need to use? If I need to plot additional points for L, what do I know the slope is going to need to be when I plot additional points? It's going to need to be the opposite. It's going to need to be the same as this line right here. Okay, so a minute ago, we made sure that what we plotted for N was opposite of ML. To plot L, it's got to be the opposite of MN. Or not the opposite, I'm saying opposite, meaning it's the opposite, it's across from it. It needs to be
N and L to have like parallel lines. So
correct, because when we draw our larger triangle, they're going to form parallel lines.
Okay.
Therefore, the slopes have to be the same. So to plot L, I'm going to have to use the slope of MN, which is going to be the 1/3 or -1/3. So notice when we get to L, I'm either going down 1 and left 3, or I'm going up 1 and right 3. I'm using that slope. And then to plot M, again, I'm having to use the slope of the side that is across from it. Okay, I'm having to use the one that would be parallel to it. And so for M, I'm going to use that slope of 2. So that means I'm going up to right 1 or down to left 1. So then I'm able to start with my midpoints. We started with this, but then I could draw the bigger triangle that includes those midpoints by using the slopes of the side that is across from the point. Okay, so the first thing is to draw your triangle using the ordered pairs that they've told you. The second thing is going to be to find the slope or to connect the lines to draw your triangle. So plot the points, connect the lines, then calculate the slopes. Then you use the slope of the side up or across from the point. I don't want to say opposite because I don't want you to do opposite slope. Across from the point to connect the other lines. Okay, does that make sense? Are there questions about that?
We're gonna be doing that a lot.
I mean, there'll be homework on it, yes. But so it's the kind of thing, that's why I'm asking if you know, the main thing to remember though is plot the points, connect the lines, find the slopes. The hardest thing is going to be to remember how to use those slopes. To use those slopes, you have to, you know that you're going to be drawing the side that is across from that point. And because they're going to be parallel to each other, that's why they have the same slope. Okay. I think for now that's enough to put on you. We'll pick up with example 5 on next Wednesday. But we do have a homework from this section, so don't close up just yet. Plus, it's only 10:03, so we've still got about 12 minutes before we go. So you have a moment to go ahead and start on that homework. So let's go ahead and take a look. I'm going to make a little start here to know that this is where we're going to start. What is that? 11. Wait a minute. We don't have class next Wednesday. We don't? No.
Yeah.
It's Veterans Day.
Crazy.
Oh, next Wednesday?
Let's just go ahead and meet anyway.
Next Wednesday?
No.
Next Wednesday, Veterans Day?
Don't y'all just want to go ahead and meet, Tyler and Keely? Let's just go ahead and meet next Wednesday. No? All right.
No, let's not.
Okay, so next Wednesday is Veterans Day, so we do not meet next Wednesday, okay? So next Thursday, we will meet, and this is where we'll pick up. I think, let's see, what is today? Help me with my days. Today is the 5th, so a week from today is the 12th, so next Wednesday is 11/11. All right, so that's not what I want to do because we said we're not meeting. So 11/12, we're going to pick up with example 5. Let's go ahead and look at our homework though for 5-4, so that means you're going to have a little extra time. Get your homework done.
That's the page.
Okay, so this will start, and actually we'll do a little bit of the practice. All right, let's look at page 290. We're on page 290. And I want you to do 12 through 18 all. 12 through 18 all. Okay, so what we'll do is you'll have the opportunity to check your odds. When we meet back, we will go through, we'll check real quick the evens. Okay, and then that'll give you time to make your corrections if you need to. So on Wednesday, we'll go through them, we'll check them. If you need to make corrections, you'll still have time before you turn that homework in. So 12 through 18 all on page 290. And
Next week, are we meeting in class?
no, next week will be virtual.
Okay.
And then let's do number 27 on page 291. Let's do 27, 28, and 29.
Page what?
This is 291, numbers 27, 28, 29. Okay, so real quick, let's go ahead and take a look at the guided practice at the top of 290. Let's start with the chill check, the skill check on number 3 through 8. So it says in exercises 3 through 9, GH, HJ, and JG are mid segments of DEF. So look at number 3. JH is parallel to what side?
DG.
Okay, so JH is parallel to what? I want to go ahead and use my whole, so let's go ahead and call it the whole side, so DF. Okay, so JH is parallel to DF. Number 4, what side is parallel to DE? So DE, what's parallel to DE? GH, good. All right, number 5. EF is equal to what? What is the measure of EF equal? Well, EH is 10.6, so what's EF going to be? No, so think about if H to E is 10.6, if this is 10.6, what is this one going to be? What's FH going to be? If this is 10.6, what is this one going to be? 10.6, so what's 10.6 plus 10.6?
That's too hard.
21.2. 6 plus 6 is 12. 10 plus 10 is 20. All right, so 21.2, all right. Then the next one says GH is equal to what? So if I'm looking at GH, how can I figure out the distance, the length of GH? It's a mid-segment. What do I know about the mid-segment?
Well,
Why?
because DE.
DE is 24, so GH is going to be 12. Good. Good. Okay, and then our next one, number 7, DF is equal to what? So look at, I'm doing DF. What is DG? 8. So what is GF? 8. So what is DF? 16. Good. All right, so if DF is 16, if this is 16, what is JH? 8. Good. Now it says find the perimeter of GHJ. So I'm finding the perimeter of GH. Whoop.
It's 8 plus 8.
It's 12 plus 12 plus 8.
Okay. What measure did we say JH was? We said this was 8, right? What did we say GH was?
12.
And so what is the measure of GJ? Remember, what did we say this measure was? 21.3? Okay. What is half of 21.3? 10.6. So what is the measure of GJ? 10.6.
Then we add all those together.
So perimeter, you just add them all together. Okay. So I use my mid-segment theorem to determine the measure of each mid-segment. Then I just add my mid-segments together to get the perimeter. So 8 plus 12 is 20. 20 plus 10.6 is going to be 30.6. All right. All righty. Then you can see here we've got the mid-segment drawn on the coordinate grid. So we know that the measure from point O, or from the origin to R, we know that the distance there from O to R is what? Now also notice here, be very careful when you're looking at your graphs. Notice that they're saying that this first line is 2. So what is this one going to be here?
4.
4, 6. So you can, and so see here, this one's 6. So that means I'm going by 2, 4, 6. So pay attention to the graphs. Make sure that they're numbered. If it's not 1, 2, 3, 4, if it's 2, 4, 6, 8, then you know that affects obviously your ordered pairs for your points. Okay. Questions? Everybody good? Everybody knows what the homework is? It's about 10:12, so we'll go ahead and get ready to start packing up. Easton? Yes, hang on just a minute. All right, so you guys online, if y'all have any questions, if y'all need any help, let me know. If y'all decide y'all want to tune in Wednesday, everybody, whoever wants to come to class Wednesday, y'all just tell me. I'll be there. No, I'm just kidding. I hope y'all have a good week, and hopefully I'll see y'all next week.
Thank you.
But let me know if y'all have questions. All right, bye y'all.